Our final lesson, 10.8 of geometry. This is the last new thing you're going to learn all year. Okay. As a review from 10.7, what we learned about the relationships of the lengths of segments that intersect. There's basically two rules you need to know, and that is dependent on where the segments intersect. So here I have two chords intersecting inside the circle. Same for number 2. Okay, so the relationship is, I'm going to call this one the blue chord, and this one the green, that whatever segments it splits the chord into, like this one's 8 and x, their products are equal to each other. So the product of 8 and x would be 8x. That's going to be the same as the product of the other segment pieces, so 14 and 12. Which 12 times 14 is 168. So then to solve this for x, you just divide by 8, you get 21. Okay, that's the rule. What? Sure. If they're inside. This one's the same. Okay, blue chord, green chord. Just a lot more variables. So this chord is split into x plus 3 and x plus 1. So their products, I would write it like this, is going to be the same as the product of the other segment pieces. X times x plus 5. You have to use parentheses here. Okay, I saw somebody do this. That doesn't say x times x plus 5. That says x times x and then add 5. That is the product. Okay, use parentheses. Be specific with your math symbols. All right, right side is pretty easy to multiply. I'll go ahead and do that. X times x is x squared plus 5x. Over here, you're just distributing as well. You just have to distribute the x. So x times x is x squared. X times 1 is x. And you have to distribute that second term. So 3. 3 times x is 3x. 3 times 1 is 3. Okay. Now I do have some like terms right here, so I'm going to go ahead and add those together. All right, now when I go to solve this, when I go to group together my like terms, you'll notice the x squareds cancel out, or they drop out. And then I'm going to go ahead and I'll move my 4x over here with the 5x. So now I'm getting 3 equals 1x. X is 3 for that one. Okay. Not a difficult problem, but you just have to know like that rule of how to find the lengths of the segments that intersect. All right, now in 3 and 4, I have a couple secant segments. Secant meaning intersecting my circle twice. And in this one, I even have a tangent segment, tangent intersecting once. And these intersect outside the circle. Can we see that? Okay, this rule is different. This rule is, still kind of think of the segment in pieces. So this secant segment, this is called my exterior piece, is 6. And in this segment, my exterior piece is 5. But this time, you don't take 5 times 13. You take the exterior piece times the length of the whole segment. Okay, that's the rule if it's exterior. So this whole segment would just be 18. What would my whole blue segment be? 6 plus x, or x plus 6. Yep, not 6x. To find that whole length, it'd be this segment plus this segment. Okay, so like I said, my rule is you take the exterior piece, so I'm going to do the blue one first, 6, times the length of the whole segment. So you take the product of those, and that's the same as the product of exterior piece times the whole piece, 18. Okay, that's how you set up this one. Quickly solving this, distribute the 6. This is 90. X is 9. Okay. The rule here is the same. What's maybe a little bit confusing is this segment, a tangent segment, all of it is the exterior part. Okay, but the rule is the same. You take the exterior part times the whole thing. They just both end up being X in this case. Okay, that's all right. Green one, exterior piece is 10. What's my whole segment? 23. Okay, so let's start with the blue one. You take the exterior piece times the length of the whole segment, and how I showed you in class. I mean, you can do this, but I said just write it as x squared. That's going to be easier to solve because x times x is x squared. That's the same as exterior piece times the whole piece. So we get here, and then we square root both sides. I'm going to write this one as a decimal, 15.2. And then towards the end of class, and I hope you watched the video if you were gone, because there's a lot of algebra reviewed over. Towards the end of class, we looked at a couple examples where I couldn't just solve it by square roots. So we reviewed over factoring, and then I showed you that quadratic formula, and there was some on your homework that you had to do each, which I made that note to you. Did anybody watch the song? Come on. Oh, okay, I'll play it if you have time. We need to know how to do those two things. I know some of us had sports yesterday, but I did have my RTI session open. It said factoring and quadratic help. If you don't know what you're doing, please come in here. And I didn't really have anybody come in, but I know some of us had sports. But that to me is like, okay, I guess they know what they're doing. Nobody's taking me up on that offer. Well, you guys, this is our last lesson together. I know you're really sad, so please try to hold back the tears. But this is it. You have to learn. The rest is just review, a couple assessments here and there, and just practice our skills for the big exam. And we're ending it with equations of circles. All right. So basically, in Chapter 10, we've been talking all about circles. Now we're going to put them on the coordinate plane with ordered pairs and stuff. And we're going to come up with the equation that forms circles. Let me compare this to something you know how to do. You guys know how to write equations of lines, right? Y equals mx plus b is slope-intercept form. Plot the y-intercept, graph the slope, yada, yada, yada. Okay, we're doing that, but instead of a line shape, it's going to make a circle shape. In order for an equation to be linear, x and y have to be in it, and there's no, like, extra symbols is kind of how I describe it. There's no, like, squarings. There's no radical symbols. X can't be in the denominator or anything like that. It's just a relationship between x and y. That's what forms that straight line, okay, where you have that rate of change, your slope. What forms a circle, and I'll show you this on decimals in a second, is if you have an equation and x and y are both being squared, okay? So what I want you to write down for the standard form of a circle, similar to like the standard form of a line or slope-intercept form of a line, how we normally write these, you're going to do parentheses, x minus... Okay, you're going to put in h, lowercase h, parentheses, and you're going to square that. I will explain these letters in just a minute. Write this down. Plus y minus k squared, just like that, equals r squared. Okay, you guys write that down quick. I'm going to pull up decimals. Okay, I'm going to type in what I just told you to write down. X minus h squared plus y minus k squared equals r squared. So, See how it forms a circle? This definitely isn't a line, right? Okay. So right now, I have these weird h, k, and r's in my equation. Right now, h and k are just set to being 1, and so is the r. Any guesses of what the r is representing in the equation? The radius. Do we agree that the radius length of this circle looks like it's 1? Careful, I'm kind of zoomed out here. Let me zoom in. There we go. If this is my center, it looks like the radius could be 1, right? Good. So if I change that number, let's make the radius 2. See how that's obviously changing now. My center's here. Now my radius is 2. Okay? Did my circle like move at all, or did the shape and size just change? Shape and size. Okay, so let's just set the radius back to 2 for a second. H and K, watch what happens when I change those. So here's what happens when I change H. Let's put it to like 4. Okay, it's shifting to the right. So it's changing the x coordinate of my center. K moves it up or down, and that's affecting the y coordinate on my center. So in that little equation, whatever h and k are, that just shifts your circle. Like if I actually go back here, if I just put h and k to be 0, it's going to be centered at the origin, right? Centered at the origin. So unless I add or subtract a number to those variables, my center is 0, 0. It's centered at the origin. And then really, and you'll learn about transformations a little bit in Algebra 2, and we do them really heavy in pre-calc. Transformations, I'm just shifting my graph around, and that affects my center. So you can actually tell what the center of your circle is in this form by looking at h and k. Center is written as a point, okay, just like this. That's what h and k represent, is the center of your circle. Whatever those numbers are, that's your center. Now, I don't know why they use the letters h and k, to be honest, but how I remember which one goes with which variable. Between x and y, which comes first alphabetically, x or y? X. Between h and k, what comes first alphabetically? H, thank you. So x and h go together in parentheses, y and k go together. And then Tyson was right. R is the radius. So we do have to square the radius in our equation. Okay, so everybody make sure you have that equation written down. We're just basically going to practice writing equations of circles when we're given different characteristics. And we have 5 levels to this. So here's level 1. Right. The equation of a circle that is centered at 4, -2 and has a radius length of 6. The only thing we need to know to write the equation is the center and the radius. And I'm given both of those things in number 1. This is why it's level 1. It's the easiest. So everybody write down, I'm doing this for 2 reasons. 1, you have your notes to look back at, so you remember how to start these. Write down that form I just told you to do. X minus h squared plus y minus k squared equals r squared. The other reason I want you to write this down is the more times you write it down, the more you start to accidentally memorize it. Okay, it'll help you. Okay, so my center, the x coordinate is h, the y coordinate is k. So I'm just going to plug those numbers in for h and k. All right, so I have x minus h, h is 4. Y minus k, y minus -2 is y plus 2. Go ahead and just simplify that as you go. Equals my radius squared, and they're telling me my radius is 6. So my final answer here would be x minus 4 squared plus y plus 2 squared equals 6 squared is 36. Now, similar to when you write equations of lines, don't write this down. But But with equations of lines, the only variables I have left in my equation are x and y, right? That should be the same in your equation of a circle. So after you plug in all your information, you kind of know you're done if your equation just has x and y in it. I should not have an equation with a bunch of numbers in it. Okay, you're writing the equation of the line. If I were to type this into Desmos, it'd form a circle centered at 4, -2, and the radius would be 6. If you don't believe me, you can try it at home. Okay, that was level 1. That was the easiest because we were given all the information we needed. Level 2, Skylar, pick your head up. Level 2, center is 1, -3. So if you wanted to right away, you're like, ooh, I know H and K. I know H and K. But this time they don't tell me what my radius is. They tell me my diameter is 10. But using my previous math knowledge, I know that my radius is just half of my diameter. So if the diameter is 10, what's the radius, folks? 5. So it's just a little extra step. So again, I'm thinking, all right, here's my equation. Write it down. I'm thinking in order to write this equation, I need H and K, and I need R. And now I have all that information. So I kind of like to do this, just like a little template. Little template of what I got to plug in. H is 1. K is -3. Y minus -3 is plus. Radius is 5. If you want to just go ahead and write that as 25, that's fine. But I will want to see that. I don't want you to leave it as 5 squared, is what I'm trying to say. I do want you to write it as 25. I want you to actually simplify that as much as you can. 25. Okay. Does anybody have questions? Ready for level 3? There's 5 levels. Level 3. Endpoints of your diameter are located at those ordered pairs. I'm not given the center. I'm not given the radius length. I'm just given 2 points on my circle that form a diameter. So if I would just do a quick sketch of my circle here, I'm not even going to make this super accurate. I'm given 2 points on my circle, but I know they form a diameter. Because it says the endpoints of your diameter are here and here. So you could say this one's at 6,3 and this one's at 2, -5. Ideas. Alejandro.
On the midpoint of the two coordinates, and that is the rate of the middle of the circle, and then distance from the diameter.
Okay. Beautiful. I'm gonna take this piece by piece. So you said I can figure out the center by finding the midpoint, right? Let's do that first. Find center. Midpoint of diameter. Okay, friends. Do you guys remember how to find midpoints? Please tell me yes. Yes.
x1 plus x2 divided by 2. The other side is y1 plus y2 divided by 2.
Good. Halfway between the x coordinates, halfway between the y coordinates. Midpoint. Point, meaning your answer should come out as an ordered pair in parentheses. All right, so halfway between my x coordinates, 2 plus 6 is 8, divided by 2 is 4. Halfway between the y coordinates, -5 plus 3 is -2, divided by 2, -1. There's your HK. There's your center. Okay. Now, what Alejandro said about finding the radius is exactly correct. We could do this 2 ways. We could do the distance of the diameter using distance formula and then take half of it. Or we could do the distance between the center and an endpoint. I'm going to show you another way to do it. If that way makes sense to you, that's fine, but I know you guys don't love distance formula. But if you love distance formula and that makes sense to you, go for it. There was one person last time who said, I want to do it that way. I said, great. It's the same answer. I'm going to kind of show you another way to do it. And I kind of like this method because you'll use it in your future math classes. We do this process a lot, if you will. So what we're going to do is we're going to use a point on our circle. I'm given 2 of them. I'm going to plug it into my equation, and I'm going to solve for my r squared. Okay? So what I mean by that, go ahead and write down your starting equation for a circle. Got it memorized yet? Okay, here's what we know right now. We know h and k, right? We know h is 4, and we know k is -1, so it's going to be +1. All right, now I'm purposely not writing x and y right now. Okay, now I just got done saying when you write an equation, make sure you have x and y in it, but we're not writing the equation yet. We're trying to still find the radius. So since this point, both of these points, are on my circle, they should be able to be plugged into my equation, and they should be solutions to my equation. They're on my circle, okay? Just like if you had a linear equation, if you plugged in the point, I don't know, 2, that means 211 is on your line, okay? Kind of similar thinking. So we're given 2 points on our circle. So I'm going to pick the one with positive numbers. So I can plug that in for x and y. I can plug that in as a point. X is 6 when y is 3. And then I can just figure out what r squared is. And I don't even need to find the r, the radius, because in my equation, I'm going to end up squaring the radius. And then this is math we can do very easy in our head, or you can use your calculator if you need to. But 6 minus 4 is what? 2. 2 squared? 4. Okay. Here, 3 plus 1 is what? 4 squared? What's 4 plus 16? 20 is r squared. And I think that's just a little bit easier than using the distance formula. Now, if you're curious what the radius is, you can square it. This gets the square root of 20 or 2 root 5, whatever. You get that same answer if you were to do distance formula. But in order to write my equation, I would just plug in my center. Which is 4 and 1. And then I would just plug this in for r squared. R squared is 20. There you go. If you were to find the radius, you would just square root 20. And then when you go to plug it back in, you just re-square it. So it just kind of saves you an extra step. I like doing that instead of distance form. And as I mentioned, you'll do this a lot in near future math classes where I'll just give you a point somewhere on your curve of some type of function, and you use that point to solve for different characteristics about your graph. So it's also good to just introduce that to you now. All right, that was level 3. Level 4. Ooh, another reason. It makes these problems easier because that's how you have to do these ones. This problem, I'm given my center, and then I'm just given a rando point on my circle. They're not telling me it's part of a diameter. Now, if you were to think of this visually, center and a random point anywhere on the circle, I could still calculate the radius by using distance formula if I wanted to. But we can do what we just did. Okay. I know h is minus -3 is plus 3, and k minus -2 is plus 2. And if I'm given a point on my circle, I could plug that in for x and y. I know when x is 1, it's like an ordered pair. They're like a duo. Y is -2. You can plug those in, and then you can figure out r squared. Whoops. Sheesh. Okay. Let's do this in our head. 4 squared, 16. 0 squared, 0. 16 is r squared. Meaning my radius would be 4 if I were to ask that, but I really don't even need to know that to write my equation. I just need to know my center. And I need to know r squared, which is 16. And plug in my center. So this is what I was saying, folks. This, in my final answer, you should have x's and y's. Okay, not at this point. This is just a little bit of solving to get there. And your final answer to your equation of a circle should have x and y. That was level 4. One last level. Okay. This time, I'm given points on my circle. I'm not given the center. They're not telling me what the radius is, but we can go ahead and plot this circle and see what we have here. Negative 8, 3 is point A. Negative 4, 7 is point B. And negative 4, negative 1 is point C. So they didn't even give me like my full circle here. So if you connect it in like a curvy fashion, which you see or you should be doing when you're graphing circles, I can see I have a semicircle here. I have about half my circle. All right, using some spatial reasoning, anybody have a guess what my other coordinate, like on the right-hand side over here, would be to make this like a perfect circle? Everybody look at your graph and count a little bit. So you can figure out what would make this perfect round circle. Guess, Lillian?
Would it be 0, 3?
0, 3, that's what I got. 0, 3. Okay, you can kind of look here. So this is a vertical distance. If you counted that length, I think it's 8. So going 8 this way. And again, just using a little bit of like spatial and visual reasoning here, that looks like that could form a perfect circle. If you really want to graph a perfect circle, you could use a compass. That's what I did. So pretty. Okay. Directions are still the same. They still want me to write this equation of this circle. Okay? So I need to find the center and I need to find the radius. Let's start with the center. Now this one, because it's nice, easy numbers, like I just said, like you count 8 by 8, you could probably figure out what the center is by just counting, but you could also use the midpoint formula if you wanted to. You can either do the midpoint of BC or the midpoint of A and that point that we found. Either way is fine. I mean, sometimes if they're not nice, clean, whole numbers, you're going to have to use the midpoint. But here I think we could all tell that my center is at negative 4, 3. Agreed? Right here is the center. Okay, really quick, I'll go ahead and show you the midpoint of, we'll say, BC. So again, this is what you would do if you maybe couldn't tell for sure. We still get negative 8 divided by 2, negative 4, 6 divided by 2. We still get that. Okay, so now our HK of our equation. So the second thing I need to do is find the radius. So again, on this one, you could probably count. If you couldn't count it, if it wasn't like directly horizontal or vertical across from each other, you would do what we did in the last example, where you just plug in a random point and like solve for r squared. Okay, but because this one is nice with my vertical, horizontal, like, I don't want to call them like vertices of my circle, but line up. What do we think our radius is in this one?
4.
4. 4. Okay, let me just write the equation. All right, center is at -4, so that changed to +4. It's always the opposite. 3. Radius is 4. So final answer, x plus 4 squared plus y minus 3 squared equals 16. You could always check your answer by quick typing this on Desmos and see if it matches your sketch. If it's way over here, probably got your center wrong. If it's way bigger, your radius is probably wrong. Okay, last problem, little word problem here. The design for a park is
At this
drawn.
time, varsity baseball can be released to get ready and load the bus. Again, varsity baseball can be released. Thank you.
Okay. The design for a park is drawn on a coordinate graph. The perimeter of the park is modeled by this equation. That's the equation that would form my circle. Each unit on the graph represents 10 feet. What is the actual area of the park? All right, so we're given the equation of the circle. I'm just going to rewrite it here. Let's think ahead for a minute with what I'm trying to find. I'm trying to find the area of the actual park. Well, if this forms a circle, I need to find the area of that circle. And how do I find the area of a circle? Pi r squared. That's how I find the area of a circle. Yes.
25 times 5.
Okay, hold on. I like your thinking, but we have to convert it first. So, I wonder if it would work to convert it after. It should work. Do it that way for a second. The only thing I need to know to find the area is my radius, right? So what Tyson just noticed is, hey, my r squared is 25. Meaning if you wanted to know just the plain old radius, what would I do? Anybody know what that is? It is 15. So what I did before I plugged it into my area, I know my radius is 15 units on a coordinate grid. I times that by the 10 feet first. That's why I'm curious if you could do it after. So that each of those 15 units represent 10 feet. So my radius in terms of feet is 150 feet. And that's what I use then to calculate my area. So in terms of the actual distance, before I calculate the square footage, the area, I converted it to 150. So you do 150 squared times pi. You guys know how to type that in your calculator? I got about this answer. Tyson, did you get 70,000-ish?
No.
Okay, so you're going to have to convert it first. And I'm guessing the reason why is because then you're not timesing pi by 10. You know what I mean? Like you're only doing the radius is what represents the 10 feet. Okay. So that'd be my answer. Feet squared. Okie-doke. That's all she wrote. Oh my God. All right.